Hello, today I'm looking at M3 International A-Level January 2016. This is question 5. A particle P of mass m is attached to one end of a light elastic string of natural length L and modulus lambda. The other end of the string is attached to a fixed point A on a smooth plane inclined at alpha to the horizontal where sine alpha is 3/5. The particle rests in equilibrium on the plane at point B, with the string lying along the line of greatest slope of the plane as shown in figure 2. Given that AB is 6/5 L, show that lambda is 3 mg. So if I look at what is happening here, then I have, this is alpha, I have my particle here, I have A here. So I will have the weight acting straight down, the mass is m, so the weight is mg. I have the normal contact force here, the reaction force, but I won't really need that because the plane is smooth and therefore friction is negligible. Then I'll have the tension acting up the slope. If I draw a dot 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 in here, this angle is also alpha. And now I can write down Newton's second law going down the slope. Now it's an equilibrium, so the acceleration is 0. So the forces going down the slope, mg sine alpha, will equal the tension, which is lambda times the extension over the natural length. So now popping in all of the values, I was told that sine alpha is 3/5. So here I get 3/5 mg equals lambda, the modulus is just lambda. The extension is going to be the difference between AB and the natural length. So I need to do 6/5 L, take away L, in other words 5/5 L. And so I get 1/5 L. And then divide by the natural length, which in fact is L. So here these L's will cancel. And to get lambda, then I just need to multiply both sides by 5, and so I get that lambda is 3 mg as required. Okay, so that part of the question is worth 3 marks. Then I'm told that the particle is pulled down the line of greatest slope to point C. So this was A, this was B here, and now it's pulled down a little further than that. And BC is 1/2 L and it's released from rest. And show that while the string remains taut, P moves with simple harmonic motion about centre B. Now, when I'm trying to prove simple harmonic motion, although I know how much further this is pulled down, I need to not use that length for the moment and just assume that the particle is now a distance x from B. So x is measured in this direction. So when the particle is now essentially here, this distance of x away. So when the particle is here, I have the weight mg. This angle is alpha. I have so the slope is here, and I still got this perpendicular force here, and here I will have the tension, which this time will be lambda over L multiplied by the extension that there was in the first part of the question, which was L over 5, plus a bit more, which I'm going to call x. So this time there will be an acceleration, and as x is measured down the slope, x double dot will also be measured down the slope. So using Newton's second law down the slope, I have mg sine alpha minus lambda over L, L over 5 plus x equals the mass, which is m, multiplied by the acceleration, x double dot. So tidying this up, sine alpha is still 3/5. I know that lambda is 3 mg, that's what I worked out in the first bit of the question. So here I have 3 mg over L, multiplied by L over 5 plus X mx double dot. So here what's going to happen is I'll get 3mg here. When I multiply out this, I'll get 3mg as well, because the L's will cancel, and so these two bits will cancel out, and so then I'll be left with minus 3mg over L multiplied by X equals mx double dot, and then I just can cancel divide through by m. In fact, I could have done that at this stage, and so I end up with x double dot is minus 3g over L x. And so that proves that I have simple harmonic motion, because I have minus omega squared x is x double dot. This is your equation for simple harmonic motion, and I can straight away read off the value of omega, which is the square root of whatever this says, whatever the coefficient of x is, this bit here, ignoring the negative sign. So here I get 3g over L, all square rooted for omega. So now the next part of the question, C, says find the greatest magnitude of the acceleration of p while the string remains taut. So the greatest acceleration occurs when x is as big as possible, because this will be as big as possible when x is as big as possible. So the magnitude of the acceleration, or the maximum, will be omega squared, so 3g over L, multiplied by the maximum that x can be, which is the amplitude, which will be how much it's actually pulled down away from the equilibrium position. So if we look back, the equilibrium position was at B, and then we were told it was pulled down a further L over 2. So L over 2 is going to be the amplitude. Yes, so, and therefore the maximum value of x. So here I can put L over 2. So the L's cancel, and I get 3g over 2 is the maximum acceleration that it can be. Now, here they wanted magnitude, so this has to be positive. And remember that when this value of x is positive, then the acceleration will be negative, because the string will try to go back to its original length. And when the value is negative, then the value of x is negative, then x double dot will be positive. So if you prefer, then you can put in a negative L over 2 over here and then do modular signs. But your result does need to be positive here, because they asked for the magnitude. Finally, it says that D is the midpoint of BC. So coming back to our diagram, B was here, C was down here, and the distance between B and C was L over 2, and that was essentially the amplitude. So D is the midpoint of BC, and it says find the time taken by P to move directly from D to the point where the string becomes slack for the first time is this. Find the value of K. Okay, so to find the time taken for the string, for the particle to move from halfway between here to when the string becomes slack, well, at D, x is going to be half of this, so half of L over 2, so in other words L over 4, and I can use the formula x equals a sine omega t. Now this is the formula that you should use when you're measuring the motion from the center to that position, but the time it's going to take to go from there to there is the same as the time it will take to go from there to there. Okay, so if I measure the time from here to here, then popping in this value will give me that amount of time to get from B to C, sorry, from B to D, or from D to B. So popping that in, I get x is L over 4, A was the amplitude, which is L over 2. Sine and omega, looking back, was this, root 3, the square root of 3g over L, multiplied by t. So dividing both sides by L, multiplying both sides by 2, then I end up with inverse sine of a half, which is pi over 6, will equal this thing. So to end up with that value of t, then I multiply by root L over 3g, and so I've got pi over 6 multiplied by that thing. Then when it says the time from D for up to when it gets slack, so this is the time from B to D or D to B, same thing. Okay, so when does it go slack? Well, it will go slack when the string goes back to its natural length, coming back up here. So if you remember, then it was extended by L over 5 initially to reach the equilibrium position, and so we would need x to be L over 5, but in this direction, so negative L over 5. But the amount of time to go from there to there or there to there is the same, L over 5 up or L over 5 down. So in order to end up with positive values everywhere, I'm going to use x is L over 5 in this case. So at E, x is L over 5. So this time I get L over 5 equals L over 2 sine that thing L over t, multiplied by t. So multiplying both, dividing both sides by L, multiplying both sides by 2, I get this. So then I'm going to do inverse sine of 2/5. So inverse sine of 2/5 gives me this answer, which is not very easy to write in terms of pi. So then I would have that this time to get from B to E is going to be root L over 3g multiplied by inverse sine of 2/5, which is this 0.4115 blah 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 value. So therefore they wanted k to 2 significant figures, so I need an L over g, so I need no square roots in here. So the total time will be this plus this. So I've got root L over g times 1 over root 3, so taking that root 3 kind of separately because I want it separate, multiplied by inverse sine of 2/5 plus pi over 6. So to get the value of k, I need to work out this bit here. So I've already done this bit, and then I add pi over 6 and then divide it by root 3, and so I get 0.5, and they wanted it to 2 significant figures, so 0.54 root L over g. Okay, so I've shown the examiner clearly what I typed in to get my answer, and to 2 significant figures, that's the value of k. So I'll just write it very clearly, therefore k is 0.54. Okay, so that part of the question was worth 4 marks. So you've got 3 plus 4 plus 2 plus 4, so altogether 13 marks for that question. Okay, I hope you found that solution helpful. Good luck with your studies.